We are now recording. Okay. All right, so how far did you guys get on the practice test?
I went through it, but I mean, there's definitely a couple, like one or two that I was like, I don't even know how to start, so I just skipped them. But
Okay.
and some I did pretty well, but I got through it.
Okay.
And a lot that I got wrong.
I'm gonna tell it to auto allow you guys to control the screen. What's that? It's done having fun with drawing.
Sorry.
Sorry, because it grabs control of the mouse is all. Let me see. Remote control. Auto accept all requests. Okay, you can go back to drawing now. Okay. So yeah. So I sent the answer sheet as well. The answer sheet does not tell you how to do the problems. It just says what the correct answer is. How well did you guys do? Did you get, I was expecting you guys to do badly, because when I started studying for the GRE, I did badly.
Met.
Okay, because I did very badly when I started studying for the GRE. And I just wanted to tell you guys that that's totally normal, because it's a whole bunch of stuff that you guys haven't done for a very long time. And so I don't want you to feel discouraged.
Well, appreciate that.
I felt discouraged.
Yeah, it was. It is discouraging to be like, shit, I don't know how to do any of this.
Mm-hmm.
Yeah.
I mean, none of it. There were a couple where I was like, okay, this makes sense.
Okay.
Is it a swing on a tree? It's cute.
Yes.
What would you guys like to go for? Well, first of all, let's kind of say like which problems. I'm gonna grab the. I'm sorry. You know, the one problem with the whiteboard is that I can't control the mouse. I'm gonna take control for a minute, okay, Adley?
Sure. Go ahead.
Okay. I'm sorry. I'm gonna pull up the practice test on my computer here so I can look at it. I did the problems. I went through all of them, and I have the correct way to solve all of them here. Let me just pull it up.
Well, I mean, should we just start from the beginning, and we can, if we
Sure.
all have tonight, we can skip it?
Sure, that's fine.
So I'm sure there's
yes.
some that were definitely not as complicated. Like.
Okay, here we go. Okay, I've got everything here now. All right. So, okay, so let's start at the very beginning. So page 2, because page 1 is just go away, stupid pop-ups into here. All right. Yeah, so page 2. Let's look at the very first question, number 1.
Parallelogram.
Well, above the parallelogram.
Above.
It's the x squared plus 1 and 2x minus 1.
Yeah, I got this one.
Mm-hmm.
Let's get it.
I don't know, but my answer is A. I didn't compare it. I was in a hurry.
Okay. Did anyone? So Adelaide said A. Did anyone get anything other than A?
No.
Okay. All right. Yeah. The answer is A. And when I did this one, I just, I went after my, a quick way to test a problem like this is, plug in 0, plug in positive something, plug in negative something. And in this case, the x squared, it's always going to return you positive numbers, right?
Yeah.
So it's pretty much always going to be greater than B here. Because even at 0, B is going to return a negative number.
But it can't be negative because it's an angle. It has to be a...
No, you're looking at the wrong thing. Question 1 has nothing to do with the parallelogram.
I thought the parallelogram was because it says
The parallelogram is question 2.
I hate the way this is formatted.
I know. I'm sorry. I copied it directly from the website. It looks just as bad on the web.
So okay, regardless of that, okay, I thought X was the angle.
Nope.
You know, and I was like, oh well, it's got to be at least probably like 45 or around 45 degrees. Okay, well, that's great.
Yeah. Okay. So question 1 is just about quantities A and B here.
Got it. Well, either way.
Yeah. I mean, it's the x squared plus 1 and the 2x minus 1.
Yeah.
Okay. But yeah. So the answer is A. So good job.
I think the parallelogram is for question 2.
Yes. Yeah. The parallelogram is for question 2. Which, speaking of question 2, let's take a look at that.
Which I got wrong. Yeah.
Okay.
I guess this brings me back to a previous question, which is like, how much can you assume being symmetrical in their drawing?
So this kind of goes back to that one problem. I'm going to go ahead and first I'm going to save this beautiful drawing.
You should print it.
Okay. And now I'm going to clear it. I did save it. It's too pretty to just erase. So I'm going to go ahead and draw a little bit. Remember the problem we had? Do you remember the problem we had where we talked about the triangle, where it said, draw the triangle with the sides, 5, 12, and 10 or whatever. And we said, okay, well, 5, 12, 10, and that drawing told us absolutely nothing, right? Mm-hmm. Until we actually drew the triangle with slightly better. Where we said, well, if it's 5, 10, and 12, like it's got to look more like this, right?
Mm-hmm.
Yeah.
So that was, the whole point of that problem was to draw the triangle well. With this, they're trying to trick you in the same way. So they drew a parallelogram that looks
equal sides, right?
So a parallelogram is just, it basically means it's slanted. So these two sides are the same length.
Yeah.
So so let's say L, L is the same, and the width is the same.
So then,
but there's nothing that says what these angles have to be. So this is a angle X and angle Y. We can draw a parallelogram, like something like this.
Oh, I see.
I
just thought it was, if you bisected it would be equal, but I guess it doesn't have to be. Could be a 0.1 degree off.
Right. Yeah. They're trying to trick you.
And they did.
Good
job.
Because when you draw it like this, now it's much more obvious that these two angles don't have to be equal, right?
Right.
Okay. So given that, now you can kind of see, all right, the angles here, we can't really tell because they're not giving us any concrete information.
Yeah.
So it's D?
Yeah, the answer for this one is D.
Now, if they said, if this was a square, then we would know bisected. But that's what I'm saying. If this was a square, we would know that all sides are equal, and therefore bisect would be 2 equal sized triangles. But that's why I'm saying, can you go off of a drawing?
Depending on the shape?
If they said this was a square, and then you had a line down from S to U.
Mm-hmm. Right. Well, a square is very different. The definition of a square is that,
yes, that's what he's saying.
That's what my question is. If they said instead of our STU is a parallelogram, but instead this was a square and it was otherwise the same question, all sides are equal, and they just drew a line, you can assume that line from corner to corner is a precise corner to corner line.
Mhm. Yeah,
Is that true?
but yes, because the definition of a square is different than that of a parallelogram.
Okay.
That's
So
my
based
point.
on-
Yeah.
Is parallelogram, yes, that's the trick. But if it was a square, could I just trust that based on visually, okay, these are equal sized triangles?
Yes, but not if it's a rectangle.
Right. Yes.
We're just basing on the rules of the shape.
Yeah, no, I get it. Okay, yeah, I get it. I'm saying like, yeah, so in a rectangle or a parallelogram, you don't know the angles, but in a square you would. But it's just like that one with the circle where we're like, from point to point, it's like, okay, you can assume this is there's not some sort of like trick thing about the drawing being.
There's a little bit with a rectangle. You know that because this is a right angle, that because these are all 90 degrees, these corners,
Yeah,
you know that whatever these two angles are on the rectangle,
they equal. Yeah.
right.
Okay.
That's about all you can tell.
But I'm saying
Because on the parallelogram, you don't have that 90-degree guarantee.
Yeah. But hypothetically, if they gave us a square and you have z, z as your square sides, and we just visually assume that those two angles are both 45.
Yes.
Okay. That's what I'm getting to. It's just like if it is a shape like a square or a circle where you have these properties of equality.
But only if they explicitly say this is a square.
This is a square. Right?
If they just tell you this is a rectangular region, you can't guarantee it.
Yeah. Okay.
They might draw it as a square, but if they don't say it's a square, don't believe that it is. Don't assume that it is.
Gotcha. Okay.
Okay.
Cool.
Okay, should we go to the circle problem on page 3?
Yeah, that one I got.
You did?
Yeah.
Yay! Good job. Do you want to draw it out for us?
Sure.
Okay, I'm going to clear the drawings. Go for it. Take control of the mouse.
Right.
And I'm going to mute myself so Adela go ahead.
How do I draw though? Oh, annotate. Cool. Draw. Oh, it worked. Yay. Okay. So we have our circle here. Oops. It's not right. This is hard to do on a mouse pad.
If you grab the eraser tool, the eraser will erase entire lines when you touch them.
Oh, cool. Okay. Got it. Perfect. And I guess I could be using straight lines for this, but too late. So this angle is 180, 160, right? Sorry, I can't. This is pretty hard to do.
It works.
So you can.
Okay. Sorry, getting used to this. Draw.
You're doing fine.
That's better. Okay, so the area, we're trying to figure out the area of this and this together.
If I understand that, yes.
Okay, so area of a circle, of the total circle, is pi
R squared.
r squared. And it gives us the radius.
6.
So pi 6 squared. So 36 pi is the whole thing. So now we have the area of the whole circle. And how did I do this? Okay, so if we know this is 160, then we know this is 160 degrees.
Yes.
And the whole thing's So that means that this is a 20-degree angle,
Mhm.
and this is a 20-degree angle. Okay?
So far follow.
So, and we need to find out, so we have the area of everything, and we need to find out if we're assuming that these are, equal cuts and that we can slice this into, however many equal-sized slices. 20 plus 160 is actually 180, which is half. So you can actually assume that this 20 out of 160, how did I do this? Sorry, I'm just looking back at my notes. 20 over 16. Oh my God. Where's, I'm like, where did my math in my brain?
It's okay, because I went all the way to trigonometry looking for radians, so.
Oh, yeah. Okay, so 20 out of 160 is, what's the, God, can someone help me reduce that fraction? Because I was doing this.
20 out of 160, that would be 2 over 80.
2 over 80.
20 out of 160, isn't it 2? I'm sorry, 10 over 8.
1
1
over
over
8.
8.
It's 8, right?
1 over 8, yeah.
1 over 8.
1/8. Okay, got it. Okay, so 1/8 of 36. So 36 divided by 8. That's not right. Okay, so let's say we're working with half of this. That's right, I forgot. We're working with half of this right now. Sorry about my ugly pie. I just basically split it in half to make the math easier, but I guess you don't need to do that. It might save a step, but that's what I ended up doing. Was like 20 out of 160 was 1/8, so 18 divided by 8 is 2.25. How the fuck did I get this? That's not right.
Again, you're far closer than I am with my radians, so.
Oh, okay, wait. Oh, it's 9. It's not 9. It's okay. 20 times 8 is 160, but that still counts as 1. So we're actually dividing by 9.
Okay, I'm sorry. Explain why again?
20 goes into 168 8 times. But what I'm actually trying to figure out is the area of this. So I need to go, so if I break this, yeah, I can break 160 into 8 slices that are the same size as this, but that's actually the 9th slice.
Okay.
Does that make sense?
Yes.
So, because I need to add these back together. So 180 is their total. And 20 out of 180 is actually 1/9, not 1/8, because I need to figure out, does that make sense? So I'm now trying to figure out what 20 is out of all of this. Doesn't matter that with the 160. So this is 20 is 1/9, 180. So 18 divided by 9 is 2 pi.
Man, I was close with my math too.
And that's the area of one of these. And so 2 of them is 4 pi. So I'm just going to multiply by 2. Oh, God, this is hard to write with. Does that make sense? I know my explanation went off the rails for a minute.
It makes sense. When I went to the trigonometry lesson on Khan Academy, it tells you like that every degree it's 1 radians. So when you have the 160 times the radian over 180 degrees, then you simplify and you get the 8 over 9, which again, that would mean that the remaining degrees would be the 1 over 9.
Yeah.
I just didn't get to that point, you see?
Yeah, the 1 over 9 is the 20 over 180.
Yeah, and I didn't think about that because, again, and my brain doesn't fully understand freaking fractions. And I would have understood that, 1 over 9 would have been the remainder of 9 over 9, which now it makes sense. And I was like, why the hell do I have 8 over 9, you know?
Could have probably saved a step, by just dividing. If 36 pi is the area of the entire circle, and you're just saying that 40, over 360 is also a ninth. So I would just divide 36 by 9 and end up with the same answer. I didn't have to divide by 2 and then multiply by 2 later. That was a waste of time, but that's where.
But that's how you figure it out.
The numbers were too big.
Okay, would you mind doing me a favor, Lee, and just write down like what you just said, like what the fastest way would have been?
How do I write that? In like draw it?
Yeah, put it there and just put like really quickly what the fastest way would have been.
Yeah, I'll just erase all of this because that was the.
Okay. Just because my notebook looks around the same, it's just the matter of me learning that radians equals degrees and they're the same in a circle.
Okay,
Which is
They are not. They are not.
Oh, they're not?
They are not.
Okay, never mind, they're not. But according to Khan Academy, every degree is 1 radian.
20 out of 360 equals 1 over 9. Right? Is that correct?
Yes.
So divide 36 pi. Is there a pi symbol? Let's just write that by 9, which equals 4 pi. Sorry, this is not right. 40 over. This is actually wrong. How do I get back to the, can I not edit it?
That's it. Once you click out, you click out.
Oh God.
You have to erase it.
You can edit the text items. You have to use the select, the thing that has the 4 arrows on it, and then you can double click into it, and then you can edit it. Also, 20 divided by 360 is not 1/9. Okay. Oh, you did fix it. Okay.
That's what I was trying to fix. It's 40. Yeah. So basically, I know the whole area. I know that 40 out of the total area is 1/9 of the circle. So I could just divide the full area by 9, and I get 4 pi. So that's it.
That would have been much more easier.
Yeah. Sorry about the lengthy explanation. It took me a minute to refigure it out.
You're fine.
Okay. Everyone get that? I want to give you guys a quick recap on radians. So degrees and radians are 2 different things. So when we talk about a circle, how many degrees are there in a circle?
360.
360.
Got it. Okay. How many radians are there in a circle? There are not 360 radians in a circle.
I don't remember what radians are at all, so I don't know.
Okay. There are 2 pi radians in a circle. So if we're talking about from here to here, you know, let's say this is our 0, right? This is our 0 angle. This would be 90 degrees or pi over 2 radians.
Why?
Adelaide asks why. Radians are a different way of measuring a circle, of measuring angles around a circle. There are 2 pi radians in the entire circle. When we get to here, this is, how many degrees is this?
180.
180. It is pi radians. So to go from here to here is either 180 degrees or 1 pi radians. If we go to the third quarter, how many degrees is this?
270.
Great, 270 degrees. This is also 3 pi over 4. And then when we get all the way back around, we're at 360 degrees or 2 pi radians. You know. Or, you know, if you're starting here, 0 degrees and 0 pi, you know, but it depends on which way you're coming from. So why do we have these two different ways of measuring the circle? These are, so pi is that very special number, right? It's the the ratio of the circumference to the diameter or something like that, right? This is a way of doing angles in reference to that.
So 2 pi radians is equal to 360 degrees.
Yes. And if you ever want to convert between radians and degrees,
Okay.
there's a way to do that.
Okay.
So you can always multiply a number by 1, right? And when you do that, you don't change its value, right? But we can make that 1 look kind of different depending on what we're trying to do, right? And we can do that to as a tool for us, part of our toolbox. So to convert a number from between radians and degrees, you multiply by 1. You multiply that number by pi over 180 if you're trying to go from degrees to radians, or 180 degrees over pi radians. So let's say I had, you know, an angle, let's call it 90 degrees, and I want to convert this to radians. I would multiply this by 1. I would multiply this by pi radians over 180 degrees. By the way, I could do times 2 pi radians over 360 degrees. That it's the same thing, right? It's still 1. So when I would do this, I would get, you know, 90 degrees times pi radians over 180 degrees. So the 90 and the 180, those get divided out, right?
Is 270 3/4 or 4/3?
270?
3/4. Excuse me.
I'm sorry.
3 halves. 3 halves. I'm sorry.
Halves.
3 pi over 2.
Okay.
I'm sorry.
Like,
I'm sorry. That's my mistake there.
no, I was just like,
Thank you for catching it. 3 pi over 2.
okay.
As in other words, 1.5. You know, 1.5 pi. Thank you for catching that. I'm sorry.
No, it's no problem. I was just like, mind is blown.
Okay. Anyways, for this though, what we're left from our conversion here is pi over 2, right? when you're doing things in physics, you oftentimes wind up converting a lot between different kinds of units. And I always found it helpful to keep my units in place as I was going between different conversions. You know, you get these things like if you're doing electricity and magnetism, like, you know, oh, watts equals amps times voltage and things. And it's like, well, amps times, if I multiply amps and voltage, that turns into watts. And if I'm dividing them out, well, if I'm dividing watts by the number of amps, well, that's gonna, you know, amps times voltage over here, divide by amps, I'm left with V for voltage. But yeah, so you can see that the degree symbol, even, you know, that gets divided out and canceled, and what's left is the pi radians. And likewise, if you're trying to go backwards, you know, if we have an angle 3 pi over 2 radians, and we want to convert that to degrees, we'd multiply that by 180 degrees over pi radians. So we get 3 pi times 180 over 2 times pi. The pi radians cancel, right? And the, you know, 180 divided by 2, we can simplify that right away. What's that get us? That gets us 90, right? Times 90. Equals 3 times 90. Oh, got my degrees. 3 times 90 degrees, and that is 270 degrees, right? So we got 90, 180, 270. Probably not something you'll need to do very often.
But can radians come up though on the GRE?
Well, I helped earlier.
It did in this problem.
That's why I started solving it with a radian circle.
So you could solve, I guess, so you could solve this using radians if you felt like it.
Well, I mean, the fact that you had pi as part of your answer, you know. And the,
like,
you know,
I got faster to the 1/9 using the radian. I just hear myself and it's weird.
You will often see radians used in trigonometry because it's often cleaner at times, and more exact. 360 degrees is less precise than using radians for doing smooth movements. But yeah, I mean, you definitely solve this the right way of keeping things in degrees, and then, you know, well, but if you have to do anything with radians, this is how the two work together. This is what, you know, 1 radian does not equal 1 degree. They are very different.
Gotcha. Alrighty.
Cool. Okay. I'm gonna save that. Shall we go on to the next question?
Yeah.
Or how are you guys doing time-wise?
Start this one.
Okay.
Because I also, there's the straight lines around the 2x. I didn't even remember what that meant.
Okay. Did anyone manage to solve this one?
Vanessa.
Vanessa is shaking her head.
I'm terrible
Okay.
at these graphs. I
Okay.
took one look at it and I was like, oh no.
Okay. No worries. No worries. Let's take a look at it. Let's go for it. All right. So we've got our number our graph here, right? And it's saying, okay, so 1, 2, 3, 4. And we know there's a point there. And we've got 1, 2, 3, 4. And we've got lines going off like this. And 1, 2, 3, 4. Right? Okay. And we're told this is y equals f of x. These lines are part of the function y equals f of x. Okay, so first thing, Lee mentioned, what are those two lines around the x? So f of x equals weird line thing, 2x, weird line thing, plus 4. Okay, does anyone know what those weird line things are?
It means that 2x, it's like an equal value, right? 2x, it's 2x. It can't be.
I'll mute myself so you can.
From what I remember.
You unmuted me.
Okay, I'm muted. So from what I remember, oops. So those lines around the 2 means that when it comes out of the 2 lines, it's going to be always positive, isn't it?
That's right.
So if it's negative 2x, it's always going to be 2x. It's not going to be a negative. It's always going to be an outcome of a positive, I think.
Right. Okay. What Adelaide said is correct. Those 2 lines, that's what's called an absolute value.
Okay. Coming back.
So absolute value. So the absolute value operator, the thing within those 2 brackets is always going to be positive. So the absolute value of 5 is 5, but the absolute value of negative 5 is also 5.
Got it.
Bathroom break.
Okay. Adelaide's requesting a quick 2-minute bathroom break.
Okay.
All right, we'll solve this problem after the break.
We need some commercial sponsors.
Did you just plug in number 5, or were you just giving an example, Scotty?
Do you want me to?
Yeah, I'm asking.
No, I mean the mute. Okay, there we go. Yeah, so for that, I was just putting in using 5 as an example. So, the absolute value operator, those 2 lines, anything that comes out of that is always going to be positive. So if you plug in 5 in the absolute value brackets, 5 is going to equal 5, but -5 will also equal 5. So that's all it is. It's just makes everything within the brackets positive. So that's why on this graph of f of x, y equals f of x, why it has that V shape, why the line isn't straight, why it like bounces.
Because it has to be always positive.
Right. Okay. Everyone ready to continue with this problem?
Yep.
Okay. So we now know what the absolute value operator is. And we know why it has this V shape. This is 1, that's 1.
Oh, so okay, so 2x plus 4, because if x is 0, you're just left with plus 4, and that's why it starts at 4.
Mm-hmm.
Okay.
Right, because what's the equation of a line?
It's going to be the y equals m times x plus b.
Right.
What?
Adelaide was saying it back there, if you guys could hear her.
No.
So I just wrote the equation of a line over the top of our f of x here.
No, I can't see.
Equation of any line?
You can or can't see it.
I saw it.
You saw it, okay.
I can see that, but that's the equation of any line?
The equation of a straight line.
Oh. Wow.
Yeah. The equation of a line is y equals mx plus b. I do remember we did talk about this, although maybe you weren't in that.
I think, well, actually, I don't know. You might have nothing.
I think you might have missed when we did that. We did a full like 15, 20 minutes on the equation of a line.
Oh, yeah, definitely not.
Okay.
Missed that one. Okay.
All right.
You don't have to re-explain it. I can. I'll assume that's true for now.
So, well, let me ask. So Vanessa, what is m?
I don't know.
Yeah.
Slope.
Or b?
Is it? No.
Okay.
Mm-mm.
Adelaide, do you remember?
The m is the slope.
Got it. Okay, Adelaide knows.
Okay.
M equals the slope of the line. And b?
I don't remember.
Okay. B is the y-intercept. So Lee made the observation, if in 2x plus 4, if x is 0, the answer is going to be 4, and that's why it's 4 up on that line. That's true of any line, basically, because any line you can write in this format of slope times x plus y-intercept.
So then slope is the rise of a run.
Right. Slope is, as I mentioned, the rise over the run, right? Or, the change in y over the change in x. So if we know that, you know, where would the next point on this line be? Without even having to plug it into the equation. If we knew we were going to move over 1 in the x, you know, how much would we go up? If we went over to x equals 1, where would y be?
X equals 1. Y would be on 1.
Well, our slope is what?
2x.
Well, not 2x, just 2, right? Which is, which if we did it as rise over run, it would be 2 over 1, right?
Okay, I get it. So it would be, our y-intercept would be, if right now we know it's at 4.
Well, what would be the next point? We would go over, to find our next point?
It would be 2 and over 1.
Right,
Positive.
got it.
Hmm.
You don't even have to plug it into the equation.
So can you repeat that? So if you're trying to figure if x is 1, then we should have up to
Right.
over 1, and then we're at and plus 4 in this instance, right? Up.
Hmm.
Does that make sense? Two over 1. Oh,
Well, I was trying to show.
There, we're already,
Yeah.
okay. So it's.
Yeah, what I'm trying to show is that you don't even have to plug it into the equation. Because you know the slope and the y-intercept,
Yeah.
you can just, if you wanted to, you could just plot, you know, you would know, oh, well, the next number is run of 1, rise of 2, run of 1, rise of 2, run of 1, rise of 2.
Right. 4 is the starting value, basically, in this instance.
It's
a y.
Right. It's your y-intercept. It's where the line crosses the y-intercept at.
Got it. Okay.
Okay. Now, given that, I can tell you that there's no more math we need to do to solve this problem. What's the problem asking for us, or asking from us?
Where does G intersect
Mm.
Y?
And not the where does G intersect
Or
Y,
where does
but
G
which ones, which G's intercept Y, if any?
Does the graph of G intersect the graph of F?
So it would be 2x plus c.
Adelaide is saying 2x plus 3. Does anyone, what do you guys think? Agree, disagree?
Well, we don't. In this one, we don't have the absolute value, so we don't know if it's positive or negative, right?
Well, it's asking you to find out. Well, can you hear me?
Yeah.
Oh, it's asking you to find out which ones of those equations.
Oh, hold on, Adelaide. Let me mute myself.
It's asking you to find out which ones of those equations are going to give you the y-intercept. So you have to use the equations there in order to know, okay, does this formula allow you to see if you're going to be touching that line, that y?
It's
If you intercept it.
it's asking if if any of these g of x's cross f of x.
So we know that anything negative, it's not going to cross those lines that you see up there because they're on the positive side. So you can safely assume that you can't pick anything negative because of the absolute value on the other equation. And then from there, if you see those equations, now that we have, you know, the slope and the y-intercept, and we know how it's going to keep them running, you should be able to determine which one of those graphs you need.
I didn't look at the answer because I didn't even start it.
I haven't, yeah, me neither. I think I just stayed at putting the formulas, and that's about it.
I don't know if that's true about that you can't discount the negative answers, because even if it starts on the bottom of the graph, what we're trying to figure out, I guess, is which angle is going to be great enough.
Well, yes, Lee, but okay, so you see that y equals mx plus b?
Yeah.
You know that b equals your y-intercept. So when you look at the formulas of g of x equals x plus minus 2, you know that 2 is your y-intercept and it's going to be negative.
Right.
And
just it intersects the y-axis at the bottom of the graph doesn't mean it's not going to eventually intersect. If it's going.
Yes, you do, because again, the f of x equals an absolute value of this of 2x. That's never going to be negative. That means that it's starting from that point. You see the graph? It does not telling you that graph or that line is going to go into the negative side. It's telling you that it's starting from there on.
Yeah, but what I'm saying is, like, if you look
let me interject here. I'm not sure if Adelaide, I'm not sure if you're understanding what the question's asking.
Oh, damn.
So take a look here. So I've drawn below our graph just a couple of lines. So when it's talking about intersecting, it's when intersecting the graph f of x. So if this black line is f of x, which of these other lines I've drawn intersect with f of x?
The green and the blue?
Right, right. So the green and the blue lines are intersecting f of x. The pink line is parallel to f of x, and it does not intersect, right?
Mm-hmm.
I think I know which one. I think I know which one's the answer.
Which one?
Okay, I'm gonna mute myself again so you guys can talk again.
Can I?
Okay, Lee, go ahead. Take it away.
Can I annotate and I draw it out? See if I can do this with straight lines.
Certainly.
Okay, I don't want to mess up your beautiful drawing here if I screw up. So can I copy that? Is that possible? All right, no, I'm just gonna draw a new one. Okay. So we have one, two. And how do I change color? Okay, so this is our starting point, right? So from what I'm understanding, the angle, the slope of this line is determined by, can you see the cursor when I'm moving this to, or no? Okay, just when I start drawing. So, MX.
Yeah, we're unable to see the cursor. We just see the lines after you're finished drawing them. Yeah. Like the whole line appears all at once.
I see, okay. So this blue line, the slope of this is determined by MX, is what we're saying, right? And the reason it's V-shaped is because it's the absolute value, which is why it jumps to go up instead of down. Because if it wasn't, it would be this way. Or because it's absolute value, it could actually, if it was negative, it might actually continue this way, right? Is that correct? If we don't know the value of x, and if we had negative value for x, it would be a negative slope. But because it's absolute value, that's how we're sure it's a V shape.
Let me jump in there real quick.
True.
So on our graph, this is positive y and negative y, right?
Yeah.
This is positive x and negative x. So in other words, as x is, even though x is negative over here, the slope,
Y value is
yeah,
positive.
yeah, the y value is positive.
So
because of that, the slope at this angle is actually a negative slope, right? Because it's going downwards. Okay, that's all I wanted to say. And then going upwards here, it's positive, but basically it just creates that V shape. So even if you have negative x values, you're still going to have positive y values because of the absolute value.
Okay, so it's So none
Okay,
of
that's
these,
all I was saying. I'll jump out now.
No. I think I understand that. So none of these options for g of x have a negative x. So nothing is going to go this way. Because, right? Oh, actually, we don't know that because we don't know if it's not an absolute value. So it could, if x is negative.
Well, that is actually a good observation. In all of the possibilities for g of x, none of the slopes are negative, right? So what does that tell you then? All of your slopes are going to look like
this.
You're going to go high up.
Right? In other words, you're not going to have any slopes that are like that, right? No slopes like that.
But unless, well, because we don't know the value of x, but if x is negative, like, so let's take the first one, for example, g of x equals x minus 2. So it's going to start here. Oh, you can't see it till it's done. But it is actually, if x is negative, it's going to go this way. If x is positive, it's going to go this way. But the slope is going to be less. It's actually going to be, it's going to be not as aggressive of a slope as this 2 because
keep in mind that none of those g of x's have an absolute value in them.
Oh, right. So it's actually going to be, oh, oops, I just fucked up. It's hard to get used to. Okay, here we go. So what that means is, because they don't have negative values, that means they're always going to be this shape. I see what you're saying. It's never going to go up on this side. I think I understand. So if we're starting, our second values are starting points. So -2 + 3, -2 + 3, or -2. So we're either starting, how do I draw a dot? We're either starting here or here, not to scale. So what we want to figure out is the angle, and which angle is going to be sharp enough to intersect this. And so if it's x.
Yes. Okay, you're on the right track.
If it's x, so this angle is 2x. So if something's 2x, so like this option C or D, whether we start up here or start down here, it's going to be parallel because it's the same slope. So it will never intersect.
You said for which letters?
For options C and D.
Okay.
Whether we start at +3 or we start at -2, our angle is the same as this one. Sorry, I keep forgetting you can't see my cursor. Which means we can eliminate C and D because they're basically parallel to our starting line.
Okay. What about A and B?
So A and B, the angle's actually going to be less sharp. So it's not only is it not going to be parallel, it's going to move further away from it as the value gets higher. So the only one that makes sense is going to be the last one, even though it starts down here, because it's going to be a sharper angle and is going to intersect probably off the chart, but it's going to intersect up there somewhere.
Nailed it.
Okay.
So yeah, the key here is noticing that the steepness of the line. So all you have to do is look at the slopes here and know that the only line that can possibly, the only way it can possibly intersect the line is if it has a steeper slope. And because these lines go off, you know, ad infinitum, you know, they're, you know, you have an infinity amount of time to catch up with that line. So even if it was a slope of 2.00000000000001, you're guaranteed that at some point off in the future it will intersect f of x because it has a slightly steeper slope.
Adelaide's not smiling. So just to clarify though,
Adelaide's just regretting the day she asked me to host these sessions, that's all.
So,
that she asked me to get her up at 10 in the morning to do these sessions.
so for this graph though, x is positive. For this version of it, if we did x was negative, if x is negative, is it just going to go this way? Because it would be a negative slope.
Yes.
No, say that again now. You mean if it was negative 3x? When you're saying if x is negative or if the slope is negative? Those are two different things.
We don't know the value of x, so it could be it's 3x minus 2, but if x is negative, we don't know that or not, right? So
when you have a graph like this,
yeah,
x is every number from positive to negative infinity. Positive infinity to negative, and negative infinity to positive infinity. It means all real numbers.
Right. So, but what I'm saying is, if just to double check myself, if I'm like, okay, let me put in a value for x, and just to make sure that they intersect, if I was going to do some sort of graphing, if I put in a positive value for x, it was going to be that positive slope line. If I decide that I want x to be -1, my line is still
the slope doesn't change.
Very, very slopey, but it's going to become a negative slope, right?
No, it doesn't.
It doesn't?
No, because there's no absolute value on these slopes down here.
Well, I'm not saying it would make that V shape, but it would go all the way through like this, or no?
When you're saying if x is negative?
Yeah.
I think what you're trying to say is if the slope was negative, right?
Right.
Right. Okay, because those are two different things.
Remember, there's an invisible number in front of x.
Okay, so I can, when you have a slope equation like this, like 3x minus 2, I can assume that x has to be positive?
No. You're mistaking x.
X is a different thing.
Okay, so it's 3x minus 2 is the negative x values are here. Got it.
If you wanted to flip that line so that it was going
then I'd
downwards,
have to be -3x.
That's
correct.
Right. Okay.
Right. Remember that the end term is the slope.
Yeah.
That's what determines slope.
Okay.
Not
so
the
negative,
x.
So if I plug in -1 for x, it's just going to end up here on the graph, but it's still going to be a positive slope in general.
Not in general. Just it's a positive slope.
I mean,
it is a positive slope.
Got it. Okay. I get it. I think. All right.
So with E, you know, the way E is going to work there. I'm just go ahead and erase this line.
Oh, yeah, that
we
works.
can actually just, you know, draw that out a little bit better. So this 3 here. So if
That
that's
was -2. What, I don't know. It's not to scale.
okay.
Oh, yeah.
I'll do it on this graph over here. So
Yeah, I didn't
so
want to mess up your pretty
1,
graph.
2, 3. Let's say that's about 3 there. Okay. So if this is well, actually no. Our y-intercept's actually at -2, right? For E.
Yeah.
Let me do a different color. Let me do red. So it'll show up a little better. Okay. So there's -2. Where's our next point going to be for this line? What's our rise over run?
Oh, it's up 3/1.
Right. So we're going to go 1, 2, 3, and 1. So our next dot is going to be here. Where's our next one? It's going to be 1, 2, 3 up and 1 over, right?
Yes.
So let me just accelerate. So 1, 2, 3, and then 1. So it's going to be about there. So if we then draw that line, it's going to look about like that. And so if I draw this line a little bit better, you can see they intercept right up there somewhere. See how that works?
My brain is totally fried.
All right. It's just about noon. How are you guys feeling?
Hungry.
Yes.
Ditto.
I think I'm going to take Vanessa's advice and actually go get Starbucks today.
Go get what?
Yay.
Starbucks, just kind of like chill for today.
Oh.
Really.
I promised Adelaide waffles sometime after this too.
Oh.
Aw.
So
Waffles.
Yes.
Where
I
else?
may make him drive all the way to Waffle Love to get that one.
To where, Waffle House?
Waffle Love? It's somewhere in, where is it?
it's like a half hour away. But it's a wonderful place where they make these Belgian waffles, but you can get like a grilled cheese sandwich with waffles for the bread,
Oh,
and
that sounds good.
and they use like really
Churro
good
waffles.
cheese. Oh man, it's
Mm.
yeah, the churro waffles, the red velvet cupcake waffles. It's
Wow.
amazing. And we haven't been able to go there because everything has been, disease
Are you even
infested.
allowed to drive 30 minutes to get food? Is that allowed?
I don't know.
Okay. Anyways,
When
so
I go out, there's a lot of cars out and about.
Yeah.
So
Mhm.
maybe.
Okay. So yeah, we'll go ahead and stop the review there. I'll go ahead and stop the recording. Good job, everyone. I'm glad that we're getting it so that everyone can draw and contribute. And it's not just me, in class. I'm really glad that you guys are all kind of like talking together and working it out together.
Working it out.
Well, thank you. Sorry to monopolize the time with
I
my
know.
little.
No
No, you
worries.
did greatly. Thank you. All right. Great seeing you both.
Okay.
I'm gonna go and get
Bye.
something to eat.
Waffles.
All
Thank
right.
you.
Bye.
Bye.
Bye. Thank you.